The mission of Flexa is to create a virtual power plant. And what that means in simple words is that consumers like you and me who need electricity can get the electricity from the photovoltaic and battery plants and do so very cheap. So you can actually reduce your electricity bills and while doing that, stabilize the grid.
Hello and welcome to the Pybites Podcast, where we talk about Python, career and mindset. We're your hosts. I'm Julian Sequeira.
And I am Bob Beldebos. If you're looking to improve your Python, your career, and learn the mindset for success, this is the podcast for you. Let's get started. Hello and welcome back, everybody. This is Bob Beldebos. We are back with the Pybites Podcast, and I'm here with Robin Beer again. Robin, how are you doing?
I'm doing great, thanks. How are you?
Yeah, great. Yeah, nice to have you back. I think you've been on, 5 episodes or more. You've hosted a couple, so people are probably well familiar with who you are. But just in case, if there are new listeners, maybe you can quickly introduce yourself. And we're going to talk today about your new work at Flexa and what you do there and the impact on the environment and all the good stuff. And of course, the stack and a lot of Python. So welcome, everybody. And let's get started. So Robin, do you want to do a quick intro?
Yeah, sure. So basically, I am a physicist, studied physics, afterwards focused on energy system optimization, co-founded one startup, Acure, where we analyze the health of battery, which is still doing great, just had a financial financing round. And now I'm with a new startup, Flexa. We will talk quite a bit about that, as you can read here. And also recently became father, so lots of new challenges and exciting things to talk about.
Yeah, awesome. A lot going on in your life, a lot of good stuff. And do you have a win of the week?
Win of the week, yes. We had one crucial feature that needed to be implemented, and we had a really great collaboration with a team, and we discussed quite a little bit about what is the best optimal solution, let's say, what is a pragmatic solution, and I think we found a really good first solution, and then we can iterate, of course, always on the next steps. So that was an exciting one.
Nice. Always knee deep into the Python and the developer.
Yeah, exactly.
Features.
I mean, on a personal note, I would say my son is now getting dangerous in the sense that he starts to crawl and turn on the belly, basically. So now we really need to make sure the house is safe.
I thought you were going to say he's touching a terminal in Python. It's becoming dangerous. Getting there. It's going fast, huh? Yeah.
Sure.
Yeah. Nice. So tell me a bit about Flexa then, and how long have you been there? Why did you join? What's the mission of the company, and what are you working on?
Yeah, cool. So the mission of Flexa is to create a virtual power plant. And what that means in simple words is that consumers like you and me who need electricity can get the electricity from the photovoltaic and battery plants and do so very cheap. So you can actually reduce your electricity bills and while doing that, stabilize the grid. And the way we do that is that we have all the different households in Germany, for example, which have photovoltaic systems and batteries. And instead of them just sending the electricity to the grid, we do it optimized for market participation. So we buy the electricity and we sell the electricity. We buy it when it's cheap, we sell it when it's expensive. And these times of when it's cheap and expensive, combined with the costs that you have in the grid, lead to a more reduced energy bill and also a stabilized grid. So let me know how much of that was clear to understand for non-energy transition people.
Yeah, no, let's unpack it a bit more. That's very interesting. So there's almost like it resonates a bit like with shares, right? Like buying and selling. So you have to kind of see when it's the optimal time, and I guess that you have to you work with a lot of data, right? So you will face a lot of data problems, I guess.
Absolutely. And actually the comparison is good because there are similar mechanisms, exactly like with shares. There is one difference, which is that we can forecast the weather, right? So we, for example, know at least a little bit how the weather may be tomorrow. So then we can already optimize for that. And we can say, based on the current forecast, it is probably cheap to buy at that time and expensive to buy at that time. And actually also based on the current market prices for those periods. So then we can place bids. But we can also sell those bits again, right? Or do the opposite. And that can actually lead to funny things. Like you can say that, hey, I want to sell at 12 o'clock because I have a battery, I have electricity that I can sell. Then you notice that actually it makes more sense to sell it a little bit later. So you can buy again for that period and then sell later. And because you have the battery, you can actually really transport that value through the time. So sometimes you can make money without even using the battery. Sometimes you can make money by shifting the energy from one time to another time. And yeah, that's all a very exciting and complex problem to solve.
Yeah, no, it sounds fascinating. So, and there's double win then, right? Because the customer will save money, but there's also like an optimization with batteries and all that, which is then good for the environment, right?
Exactly. And I think the environment aspect is the one part, but what's really important to me is that we have come to a point where photovoltaic combined with batteries is the cheapest source of electricity. So there's a nice study, and maybe we can link it, which shows that nuclear energy, gas energy, oil, coal, and so on, they are now more expensive if you would add add new capacities than if you install PV and batteries. But that's only if you look at it from the perspective that you invest money in the beginning, you pay a certain credit for that, and then it supplies you with electricity. Now, to manage that, this also works in a cost-optimal way. Of course, you need to run the photovoltaic plants and batteries in an optimal way. And that's what we are now working on, kind of. So how to run it so that it even stabilizes the grid and makes the whole energy system even more cheap.
Wow. So, yeah. And the batteries themselves, I mean, I guess they have a life cycle and a cost as well, right? To renew them, or how does that work?
Yeah, exactly. So depending on the chemistry and so on, it can get a bit more complicated. But in general, you would expect the battery to have a certain lifetime. Same for the PV panels. But PV panels, you can calculate with 30, 40 years of duration. You only need to change some technical aspects of it, like the inverters and so on. The batteries will probably not age that long, I mean, hold that long. But maybe depending on the battery, depending on how you use it, 5, 10, 20 years. So that's something that we also keep in mind, that we operate the battery in a way that the lifetime is not negatively affected, or if it is negatively affected, that you get more value out of it by what you earn from the markets than what you lose because you need to replace the battery earlier.
Yeah. So it sounds pretty in line with what you were doing at Acure as well, right? Because you were working with batteries there as well. So what trends have you seen since in the industry?
Yeah, I would say that especially in Germany, but also in the world in general, there has been kind of like a battery explosion. So you see lots of batteries being installed right now. And that's on the one side because batteries have become even more cheap. So similar to PV, but not as fast, a little bit with delay. But the batteries are reducing a lot in prices. So it's now much cheaper to buy photovoltaic or batteries than 10, 20 years ago. I think PV panels have reduced by a factor of 100 in cost, and batteries, I'm not 100% sure, but also significantly. So you can imagine that the cheaper it gets, the more people want to invest because there are now more and more market opportunities that are viable for batteries. On the other side, in the German electricity market, the prices have also increased quite a bit due to the Russian-Ukrainian war. And in relation to that, so you have higher electricity prices, maybe also higher spreads. So spread is when the difference between the high price and the low price during a day, for example, when they also are increased. Of course, there's also more market opportunity for batteries. So there are a lot of investments now, and this will also lead to cheaper electricity prices than overall because the batteries exactly can supply electricity when it's in demand, so when people are willing to pay more, and overall that should reduce the electricity price.
Cool. So let's talk a bit about the programming language stack, and maybe also how it is to work there, and because you're pretty used to working in startups, so maybe start with the stack you're using. I guess it's a lot of Python, right? So tell me a bit what you guys use?
Yeah, exactly. Great question. So, of course, to build such a complex system, there's a lot of things needed. And we use, for example, a cloud provider, AWS, to install all the infrastructure, right? And it needs to be very scalable to handle tens of thousands of households. And so our work on that is that we build some components of the whole VPP. And for that, we use Python as a language for everything, actually, infrastructure as code, as well as just the algorithms and so on. And on the other side, we have, of course, the typical Python libraries, pandas, and Streamlit for dashboarding, for example, but also more machine learning libraries, for example. And then for the infrastructure as code, we use Pulumi then to write the infrastructure in Python code. And so what we do is really mostly work in Python every day. We have a little bit of TypeScript code as well for some dashboards or some visualizations, but that's really just a thin layer on top, I would say.
And those dashboards, is that more internal, or what is used for the front end for the end customer? Or is there not too much interfacing?
Yeah, that's exactly the point, right? Yeah, we have some infrastructure dashboards, let's say, for monitoring and so on, where we have a different stack, right? There's more, the importance is that it's real time or has all the different sources covered. We have, for example, Streamlit for internal dashboards when we want to have a quick analysis or an overview over something, which is more close to Jupyter notebooks, for example, but where you want to at least have that in a dashboard form. And finally, when we create reports or have something which we present to externals, we decided to go with TypeScript because then we are really more free in how we can design the dashboard. Whereas with Streamlit, for example, you would be a little bit limited, and same with other monitoring services.
Yeah, cool. Tell me a bit about some of the challenges you've had, and as far as you can share, of course. But I'm really curious. Tell me some of the complexities you're facing.
Yeah, so I would say on the one side, it's a lot of moving parts, right? So we have thousands of households that all need to be aggregated because you cannot trade households in the market. You need to trade bigger entities. Then we have forecasts for each one of these households. We also have forecasts for the ensemble of households, for example. And there are a lot of parts to improve. So you can spend an arbitrary amount of time, let's say, to optimize one single part of this whole chain. But you need to identify what is the most critical thing, or the one that brings the best return on investment in sense of developer time. So you need to have this awareness of the whole stack, let's say, on the one side from the tech perspective, and on the other side from the energy perspective, so energy market, but also physical, technical perspective. So how does a battery operate, and at which parts is it very expensive, or does the battery age faster, and in which parts it ages slower, and so on. So it has a very high dimensionality of problem in the problem space, and therefore also high dimensionality in the solution space. And it's not always clear what is the best way, let's say. And it's also very hard for any single human being to have the depth of understanding in all of these dimensions. So it's really great to have a great team where we bring different skills together. So some bringing more the infrastructure knowledge, for example, or software engineering in general. Some bring the energy perspective with some Python on top of it. And some bring more the data science perspective, right? Like how to analyze data, machine learning, or classic data science, and just mathematics as well. So we kind of need deep understanding on all these levels. So you need people that have a broad understanding of the tech stack, like I mentioned, but then also a deep understanding of one aspect of it. And that makes it also really challenging in the sense of communication, of course, because if you come from the different domains, you understand something different of words that may be very similar, right? So creating that common language, common understanding of things, that's really exciting, challenging, but I think also really rewarding. So yeah, that's great to work on.
Yeah, it sounds like an environment where you can learn a lot, and you have like these deep business problems. So it's far exceeds the code and algorithms, right? You really have to know a lot about the environment and the batteries and the physical stuff as well. Julian had a cool question as well about the load balancing across so many households, how it impacts the average person. Is it done in such a way that people don't even notice? And how do you deal with peak periods, dinner time, and seasons, middle of the winter heating versus summer cooling? Do you want to speak to that?
Yeah, for sure. Shout out to Julian also. Great question.
Yeah, he's probably asleep right now.
I mean, Australia is also really advanced in terms of renewables. So similar to Germany and some other countries that really already have to solve problems that you get only when you're at a certain stage in the energy transition. And how we solve it is basically that, on the one side, we have big pools, right? So we do forecast for the different single households, but on the other side, when you aggregate it to a pool, they level each other out maybe. So if we do the trades on the market, we need to do it for the whole pool. So it means that maybe one household in one 15-minute delivery time uses a little bit less electricity. Another one uses a little bit more. And so it statistically already balances itself to some degree, maybe, because maybe you take the shower 15 minutes earlier or later in the morning, or have some other consumption a little bit later or earlier. But of course, there's also the aspect that maybe we use the forecast that said that at 2 a.m. or maybe rather say 2 p.m., the sun would shine with this and this amount. And then over the whole region, we have this different amount of energy. Or it comes 15 minutes later or so. So then it's not so much anymore about balancing between households, but more how do we react to that situation in general. And when we do such a reaction, then of course the question is, should we take more energy from the one set of households, let's say, that have one type of batteries, or do we take it from another set of households? And how do we make all these parts sure? So we have a complex optimization algorithm, I would say, that keeps different things in mind. So on the one side, what I mentioned, the battery aging. On the other side, how the batteries, how the grid costs are, or how full the batteries are, and so on and so forth. So that ideally we can always react well in the next delivery period, so on the next time. And yeah, that's a very complex part. So I hope it's a complex answer to a seemingly simple question, and that's always the case in this part. So if you look at this machine, how it works in detail, it's really fascinating.
Yeah, and are there any resources if people are interested to dive deeper?
Mm-hmm. Yeah, so there's quite some research, of course. So if you want to look at it from the scientific perspective, from the data problem perspective. On the other side, there are some companies that have decent documentation. For example, in our case, NPAL describes some of the parts of how the energy market works and so on. NPAL is the company that has all the PV panels and batteries that we help optimize. And and then, of course, just reach out to me. So I'm always happy to answer questions, join the Pybites community, and in the circle, we can have some discussions about this.
Yeah, it's pretty easy to find you. Do you want to share anything else about Flexa, or what you're working on, or what maybe is coming and the trends over the coming years? What do you see?
Mm-hmm. Yeah, so what I see is on the one side, there are some movements that push back against renewables. So I think it's now technically in the energy system optimization community and so on, there's mostly agreement that the prices are falling quickly and the renewables are deployed exponentially increasing. And we will also see benefits in terms of the reducing electricity prices. But it takes some time, right? So there may be some pushback. But on the other side, a lot of investors have invested in batteries because it's economically interesting. And it will be more and more interesting for me personally to see how everyone can invest in batteries. Like you and me, if you have a bit of money and you think about investing in real estate or renewable energy or so, that there will be more and more opportunities that you can also profit from this transition, because why should only the big investors profit from it, right? So yeah, I think it's really exciting to look at this development and solve some of these complex problems. And if people like who are listening, software engineers, data scientists or so, are interested in solving complex problems and facing complex problems, and the joy of accelerating energy transition and doing something good, then also looking forward to talk to you, because we are always in search of talents and people who have drive and want to push things forward.
Awesome. Well, that's cool. And maybe a last question before doing the books. So you joined the startup, and it's a pretty young startup, right? How many years is Flexa
we're
already?
founded. So it's founded last year and works closely together with two parent companies, let's say Enpal and Entrix. And all together, so this is one piece of the solution, which is very central, let's say, where we have a lot of insight in the whole tool chain. Entrix is also really exciting because they optimize batteries for big assets. So what we say megawatt scale. Entrix is a bit older, and Enpal, also the parent company, is one of the few unicorns of Europe. So startups that have a valuation of a billion in German, in English. So basically, it's a really exciting environment, and so we are both kind of a very young startup, where we had the pleasure to do things from scratch and still create resources from scratch, kind of. But on the other side, we have quite some support from mature company and startup.
Yeah, cool. So where is Flexa based?
We are based in Munich, so I would say it's a very beautiful city in the middle of Europe, and you are quick in Italy, quick in the different parts of Germany, and there's a lot of mountains around for skiing in the winter or for biking in the summer, hiking, whatever you want to do, there's nature around, so you can enjoy. And we also have the second office kind of in Berlin with Enpal. So Enpal is based in Berlin, so a lot of our colleagues are frequently going back and forth between Berlin and Munich. So that could also be an option if you're more interested in Berlin, then maybe with Enpal it could work, or otherwise Munich is a great city. Yeah, so we're really happy. Also with the sun, it's good place to be.
Yeah, nice places to work. Cool. So for the audience of Python developers, if they have the aspiration to join a startup and it's just fast paced, and aside from having the domain knowledge which is required in this case, what are some tips to get up to speed quickly in such an environment and as a developer?
Yeah, just to clarify, so you don't need to have all the domain knowledge. It's also fine if you have no background in energy at all. It's just important that you have in one part of the things that I mentioned, a deep understanding. And ideally also have a broad understanding, or at least some touch with the other things. And I think that also is true in general as a software engineer. So like we also do in the PDM program, having a little bit touched all the different parts, right? So that you know a little bit about CI/CD, testing, Docker, just software development in general, but also Python development, like having in the T-shaped employee, if you call it, this bar on the top, so that you know a little bit about these things, because this helps you to connect with everything. And this helps you also that you can be independent, right? That you can create PRs in different repos and do things on your own, and then you just get approval or feedback. And then, of course, have one thing where you're more maybe really deep understanding. So either it is just pure Python, right? That you know Python really well, or maybe you really like cloud infrastructure or data engineering. So you really like how to create data pipelines that are efficient and scalable and so on. Or you're really deep into energy and you know this domain really well. And I think that's something I would recommend in general to developers. Develop like yourself in the broad direction, so that you can do things alone and also can connect with different people, and then focus on something that you really like in more detail. And this something that you really like, as I said, could be either technical or also just a domain like energy. And maybe you're not the greatest developer, but you have a deep understanding of energy and a decent understanding of the basics of the other things. Then you can also become an entrepreneur or build your own product or so, and hire the people that are the experts in the other fields.
Yeah, I think that's great advice. Go deep, but definitely also stay wide, because there's just, it's not only the Python, right? You have to deploy app, no Docker, CI/CD, and all these things we do in PDM. We have in our certification checklist. But then it's also good to go deep on something, and you might not know, right, till you land such a position. But in order to get up to speed, you need to have that wide orientation. So I think that's great. Yeah, cool. I think lastly, we always do the books, of course. So what are you reading and or learning?
Yeah, good point. So at the one, I now have some time when my son is napping. Then I also read a book maybe because he's sleeping on my arm or so. That's really a nice moment. So I started to read a little bit more again. And on the one side, Tribe of Mentors, because oftentimes it's a short nap, right? So it's nice to see, read that book where you see how different people achieve what they achieved. And it's really inspiring, short biographies, you could say. And on the other side, the Python architecture patterns, a classic from the Python books, let's say, which describes some design patterns and so on, which are really helpful. That also I have come across now whenever you build a more complex software that has different depths, let's say, that you abstract different layers, and that's really helpful in this context as well.
The Ari Percival, right? Design pattern book.
Yes, I need to check again. I'm bad with names, but we will link.
O'Reilly one, right? With a snake on.
Yes, exactly.
Yeah. And Tribe of Mentors by Tim Ferriss, right?
Yes, exactly.
Yeah, I like that one. Because he has his podcast, and these are like short summaries or short bios, I should say, right? So they're quick to digest, and you get all the lessons. So
perfect to read 1 or 2 short biographies during a 15-minute nap of the sun before he wants to play with you again.
Yeah, like the Daily Stoic, like you have this daily entry, and you can read it in 1 or 2 minutes, and you have a valuable nugget.
Yeah, exactly. And awesome. You also asked in terms of learning. There's so much I learned, right? We have great colleagues which have really deep knowledge in different directions. So every day learn a lot about this day's cloud infrastructure, but also data science a little bit. Then the energy field, of course, also going deeper. So I think it's very broad.
Yeah, awesome. Well, a lot of good stuff, and we'll link any resources and research if people want to go deeper. This was good for general overview. Happy to have caught up, and thanks for sharing. Any parting words or things I didn't ask you want to share? Now's the moment.
Yeah, I would say I think it's great here to be in an environment where people are facing complex challenges, right? And complexity itself. And I think it does sometimes have to simplify it to some degree. But I think in general, it would be good if people are courageous to face complexity instead of running away from it. And it's possible to solve complex problems. SpaceX showed it with the rockets. Here, it's also a very complex problem to solve. And as a society, I think in general, it would be good if we are more courageous towards complexity and debates, discussions that are productive and constructive. So that really makes me hopeful for the future to be in a place where this is done.
Yeah, which brings us full circle to the mindset.
Exactly.
On that note, have you been completely stuck with something and really feeling that uncomfort? And if so, how do you deal with that?
Yeah,
that was the question. That was the missing question I had.
Missing question for mindset. And shout out to Julie.
If he's not here, I tend to forget.
Probably almost every day, but not every day. Because we built something complex, it's also something that hasn't been done much on that scale before. There were 1 or 2 companies maybe who tried, but also not in this depth that we do it. So whenever you do something that hasn't been done before, of course, you have to figure out ways for problems that haven't been solved before. And that means that you cannot go to Stack Overflow or ask ChatGPT, prompt ChatGPT on a solution how it is usually done. So you can hallucinate yourself, or maybe with the help of prompts with LLMs, things that could work. You try them out, and then because it's also complex in the different ways of infrastructure and so on, it can be that you get into really edge case of how you could use the tool and so on. And then documentation is not always great, or sometimes you just don't read it. So you get stuck. But it really helps for me to make a break, for example. The other day also we were bouldering with a colleague, and we said okay, this is now a route that is too tough. I just don't get it. My arms are getting too sore and so on. In the same way, it can go with software development. And sometimes it just helps to go away from the problem, maybe sleep, do some other things. And then the next day you tackle it again and it works. So for example, today he wrote me the route he tried on the other day when we went together. Today he just made it, just worked. And I think that's also something where you can trust your brain that it will make connections that you don't see yet, and that helps. And the other thing is rubber ducking, basically. So just explaining your problem to a rubber duck or a colleague may lead you to think about it in a different way, that you see a solution. That has happened a couple of times just alone in this week, where I called a colleague, or a colleague called me, explained the problem, and then said, okay, yeah, I know the solution already. So if you're a developer and don't have a rubber duck yet, invest in a rubber duck. It's maybe the best return on invest that you can get.
Or rubber snake, yeah.
Or rubber snake. We should have a Pybites rubber snake. That would be amazing.
We should add it to the merch shop. That's not a bad idea, actually. It's kind of like teaching, right? Like when you rubber ducking it, you have to explain it. And I read somewhere again today, like until you can teach it to somebody, until you're fluent in that teaching of the concept, you won't be. Till then, you won't have understood it fully, right? And so I guess that similar process happens when you're doing rubber duck debugging, and it becomes clear. So yeah, that's great. And stepping away, that's so important. And it's also very hard to do because we get so tenacious and we keep on going. And but yeah, that's when you actually have to step back. Do you guys also pair program?
Yes, exactly. Yeah, so that also helped quite a bit. It's for us, I think, fluid. So sometimes we do it more, sometimes we do it less again, because everyone is on their path, let's say, solving their part of the problem. But it's good to know that there's always the option to do it, and colleagues that are also motivated to do it and have experience how it helps you. And I think while it is important to step away at some point, or let's say maybe just temporarily optimal, sometimes it really also just helps to bang your head against that wall long enough and just get that problem solved. But it's always like you should always, if you have tried it already one day and banged your head against it, then maybe the next day you can try some different strategies and one of them will work.
Yeah, awesome. Cool. Well, thanks for hopping on and sharing. Really cool stuff you're doing. And yeah, this is awesome. And we'll link all the resources below. And of course, people, if you want to learn more, reach out to Robin. It's easy to find. Just join our Circle community and hit him up. It's Robin Beer. All right, cool. Well, thanks for joining. And yeah, have a great day.
See you next time. Bye.
Hey everyone, thanks for tuning into the Pybites podcast. I really hope you enjoyed it. A quick message from me and Bob before you go. To get the most out of your experience with Pybites, including learning more Python, engaging with other developers, learning about our guests, discussing these podcast episodes, and much, much more, please join our community at pybites.circle.so. The link is on the screen if you're watching this on YouTube, and it's in the show notes for everyone else. When you join, make sure you introduce yourself, engage with myself and Bob, and the many other developers in the community. It's one of the greatest things you can do to expand your knowledge and reach and network as a Python developer. We'll see you in the next episode, and we will see you in the community.